Hello everyone, my name is Anuj Kumar Pandey from CSC branch, section D of Bajaj Institute of Technology. Today I am here to elaborate my PPT on the topic of round robin schedule. I will elaborate their introduction, explanation with an example and their running code. Let's start the introduction of round robin scheduling. Round robin is a scheduling algorithm used in computer systems, especially in operating systems, to allocate resources among multiple processes in a fair and balanced manner. It is a primitive algorithm, meaning it switches between processes at fixed time interval called quantum time. Here is explanation of round robin algorithm. The round robin algorithm ensures that no single process monopolizes the CPU for an extended period, promoting fairness and responsiveness among multiple processes. If a process requires more CPU time than its time slice, it is temporarily suspended and placed back at the end of queue. Let's illustrate round robin with an example. Consider the following processes with their respective CPU burst time. In this example, there are four processes P1, P2, P3 with their arrival time and respective burst time. And assume that time quantum for this round robin is 2 milliseconds. Let's understand the example. Here P1 will enter in ready queue because the arrival time of P1 is 0, and now P1 will added to running queue according to their arrival time from 0. P1 will run 0 to 2 millisecond because there is given quantum time of processes, that is 2 milliseconds. Now process has run up to 2 milliseconds, so P2 and P3 will added to ready queue because processes have covered 2 milliseconds and P2 and P3 are in process. Now P1 now P2 will added to running queue and P1 will be added to ready queue because there is 3 milliseconds left in P1 burst time. So now P2 will run from 2 to 4 milliseconds according to time quantum. Then after we can see processes has run up to 4 milliseconds, and we can see P4 we have also arrived to P4, so P4 will added to ready. P4 will added to ready queue. Now P3 will added to running queue, which will run from 4 millisecond to 6 millisecond according to time quantum. After that P1 will run from 6 to 8 millisecond, then P4 will run from 8 to 9 millisecond because P4 burst time is 1 millisecond. Then after P2 will be added to ready queue because there are 2 milliseconds left and P1 has left again 1 millisecond. So P2 will set it to running queue from 9 to 11 millisecond. Then after P1 will run in ready queue from 11 to 12 millisecond. Let's understand the code for round robin scheduling. Here we are defining the header file as include stdio.h. Now we have to define how much process the code will accept. The code here we have defined max processes 10. It means that the code will accept max to max 10 processes. Now we are defining process, that is we are structuring the process that will look like this: struct process semicolon int burst time int remaining time semicolon close. Now we are creating a function that is void with name round robin that will accept the parameters int n, that is number of process, struct processes, that is processes, and int quantum, that is quantum number. In this function we define int current time is equal to 0 and completed processes is equal to 0. Now we will run a loop up to process is completed. Now while completed processes is less than n, in this while loop we run a for loop, that is from 0 to number of processes, that is n. We will start the loop for int I is equal to 0, I is less than n, and I plus plus. In this for loop we check a condition: if processes I dot remaining time is greater than 0, int execution time is equal to processes I dot remaining time is less than quantum, or processes I dot remaining time is quantum. Now processes I dot remaining time minus equal to execution time, and current time plus equal to execution time. Under this if condition we printf process %d executed for %d units dot remaining time %d \n, which are assigned to I execution time, processes I dot remaining time. Under this if condition we will also add a new if condition, that is if processes I dot remaining time equal to 0, the completed processes plus plus. It means that process will be completed process will be one more increment. Here now we have completed the function part. Now we are coming to the main function, that is int main. We are defining here int n, that is number of processes, and struct processes max processes, and int quantum. Now we will printf enter the number of processes which will accept the number of processes scanf %d \n. Scanf %d and %n. Now again we will printf enter burst time for each processes. Now we are taking the bus time for every processes accordingly. For this we will create a loop for bus time from 0 to up to number of processes. For this we will create this loop for int I is equal to 0, I is less than n, I plus plus. Under this loop we will printf processes %d bus time I. Here this loop will accept bus time for every processes. Scanf %d and processes I dot bus time, processes I dot remaining time is equal to processes I dot bus time. Now after that finishing loop we will again print to ask the time quantum. Printf enter the quantum time, that will accept the quantum number in form scanf %d and %quantum. And now finally we will run the function of round robin, that is round robin n processes quantum. Look at this output for round robin code. Here we have entered the 5 processes that has asked by the code. Enter the number of processes, that is 5. Now we have entered the bus time for each processes. Look, enter bus time for each processes. Process 0 bus time is 5, process 1 bus time 7, process 2 bus time 2, process 3rd bus time is 8, process 4 bus time is 7. Now we have entered the time quantum, that is 6. Now code has executed and given the given the process ready queue and given the running queue. Process 0 executed for 5 units and remaining time will 0. Process 1 has executed for 6 units and given running time 1. Process 2 executed for 2 units, given remaining time 0. Process 3 executed for Process 3 executed for 6 units and given remaining time 2. Process 4 executed for 6 units, given remaining time 1. Now process 1 executed for 1 unit, remaining time 0. That's all. These are the explanations about round robin scheduling. Thank you.